Antidote. So now firstly we will see what is poison. So definition of poison in biology, poisons are substances that cause disturbances in organism, usually by chemical reaction or other activity on the molecular scale when an organism absorbs a sufficient quantity. Then what is antidote? Antidote is any substance which reverse, counteract, stop the effect of poison. Then what are antidotes? So what are the different types of poisons? Acute poisoning is exposure to a poison on one occasion or during a short period of time. Symptoms develop in a close relation to the exposure. Absorption of a poison is necessary for systemic poisoning. In contrast, substances that destroy tissue but do not absorb, such as lye, are classified as corrosive rather than poison. Furthermore, many common household medications are not labeled with skull and crossbone, although they can cause several illness or even death. In the medical sense, poisoning can be caused by less dangerous substances than those legally classified as a poison. Chronic poisoning is a long term, repeated, or continuous exposure to a poison where symptoms do not occur immediately or after each exposure. The patient gradually becomes ill or become ill after a long latent period. Chronic poisoning most commonly occurs following exposure to poisons that bioaccumulated or are biomagnified, such as mercury, gadolinium, and lead. Classification depending on their mechanism of antidote are classified into: first one is physiological antidote. It counteracts the effect of poison by producing the other physiological effects. Example: sodium nitrite in cyanide poisoning. Then second classification, chemical antidote. It changes chemical nature of poison. Example: sodium thiosulfate in cyanide poisoning. Chelating agent: sodium and calcium editate. Mechanical antidote: they prevent absorption of poison across the intestinal wall by adsorbing the toxins onto their surfaces. Example: activated charcoal and kaolin. Role of antidote in cyanide poisoning. In cyanide poisoning, sodium nitrite or sodium thiosulfate are used as antidotes. Firstly, injection of sodium nitrite is given, which causes the oxidation of ferrous ion of hemoglobin to the ferric ion of methamoglobin. The methamoglobin then combines with cerium cyanide that has not yet entered the cell to produce cyanomethamoglobin, thus protecting the essential cytochrome oxidase enzyme from the cyanide ion. This cytochrome oxidase enzyme is required for electron transfer cycle and cellular respiration. After 5 minutes, a slow intravenous infusion of sodium thiosulfate is given. The thiosulfate ions react with cyanide ion in presence of rhodonase enzyme to non-toxic thiocyanate ion, which is excreted from the urine. So first monograph from antidote, sodium thiosulfate. Molecular formula: Na2S2O3, 5 molecules of H2O, molecular weight 248.2. Sodium thiosulfate contain not less than 99% and not more than 101% of sodium thiosulfate. Properties: colorless large crystals or a coarse crystalline powder, odorless, deliquescent in moist air and efflorescent in dry air at temperature above 30 degrees Celsius. It dissolved in its water of crystallization at about 49 degrees Celsius. Preparation: it can be prepared by boiling sodium sulfite with sulfur. Here is a reaction: sodium sulfite plus sulfur we will gives sodium thiosulfate, that is Na2S2O3. Assay: weight accurately about 0.5 gram dissolved in 20 ml of water and titrate with 0.05 molar iodine using starch solution added towards the end of the titration as an indicator. So here is the factor: 1 ml of 0.05 molar iodine is equivalent to 0.02482 gram of sodium thiosulfate. Storage: store in a clean and dry place protected from moisture. Uses: it has been included in pharmacopoeia as an antidote for cyanide poisoning. For this purpose, 10% weight by volume solution is used intravenously through a 2.98% weight by volume solution is isotonic with serum. Sodium thiosulfate is also a very important reducing agent and is used as a standard titrant in iodometric titration. Next monograph: activated charcoal. It is a residue from the destructive distillation of various organic materials treated with especially to increase its absorptive power. Properties: it is a fine, black, odorless, tasteless powder free from gritty material. Activated carbon is usually derived from charcoal and is sometimes utilized as a biochar. Those derived from coal and coke are referred as activated coal and activated coke respectively. Uses: it is used as an absorbent in the treatment of diarrhea. It is also used as an antidote in drug poisoning. Activated carbon is used in gas purification, defumination, gold purification, metal extraction, water purification, medicine, sewage treatment, air filters in gas masks and respirators, filters in compression air, and many other applications. Next example: sodium nitrite. Molecular formula: NaNO2, molecular weight 69. It contains not less than 97% and not more than 101% sodium nitrite with reference to substance dried over silica gel. Properties: sodium nitrite occur in the form of white granular powder or as a white crystals having a saline taste. It is a water soluble, sparingly soluble in alcohol. When exposed to air, it deliquescent and gets slowly oxidized to sodium nitrite. It is easily decomposed by acidification with dilute sulfuric acid. Specially, it acts as a reducing agent and get oxidized in acidic medium. Preparation: it is manufactured by many methods. The most suitable method involves passing of nitrogen oxide gas obtained during the catalytic oxidation of ammonia and oxygen in sodium carbonate solution. The solution is concentrated to crystallize out the product. So here is a reaction. Here is a nitrogen oxide gas, oxygen plus Na2CO3, that is sodium carbonate. So we will get sodium nitrite plus CO2. Uses of sodium nitrite: first, in medicine, it was used as a vasodilator but has been now largely replaced by organic nitrites and nitrates, nitroglycerin, isosorbide dinitrate. Medicinally, it is mainly used as an antidote in a cyanide poisoning and has a hypotensive effect. It has a relaxant action on smooth muscles. Rusting of surgical instrument is prevented when immersed in a dilute solution. It is also used as a food preservative. So here is the list of antidotes along with the types of poisoning treated. So sodium nitrite for cyanide poisoning, sodium thiosulfate for cyanide poisoning, dysferrioxamine is for iron salt, bal or mercaptol is used for mercury salt, penicillamine is used for copper and lead salt, calcium chloride for fluoride, hydrogen peroxide for phosphorus. And these all are the references. Thank you.